So guys, we are now present now this video with the lesson notes for the students as the teacher is teaching this topic integers. So we'll have a discussion through this video on the integers. We have a discussion where now we have introduction to integers now for the junior secondary classes, and this one makes them now powerful when they come to the choices of courses when they go ahead in their careers. Remember, what I'm doing is I'm laying the foundation of mathematics, and the foundation is very important in anything. If, for example, you are building a house without a good foundation, then you are sure it's not going to take very many years. Everything with good foundation always succeeds. So guys, why don't we continue giving you the foundation of this famous subject known as mathematics, which always, if you are good in it, you are going to always be orderly. You organize your things, you are organized, and everything of yours goes very well if you like mathematics. People who fear mathematics are sometimes disorderly, all right? Including ladies in the kitchen. If you hate mathematics, you find you are knocking furious here and there and so on, chaotic. So anybody who has got mathematics background is always happy because you deal with life's issues in an orderly manner, an orderly sequence, relaxed. It trains you to be relaxed and focused. So guys, let's go to the lesson notes. So welcome to lesson notes, integers. The subject is mathematics and the introduction to integers, the basics, and the level, of course, ages 11 to 14. So we begin the lesson notes by the definition of integers, where we say integers are the set of whole numbers and their negative counterparts, including zero. Did you know that, guys, before? Welcome to that definition. Excuse me, guys. It's because I've talked from morning to now, late afternoon. So they are represented as, you see, we have zero here. You see this zero here? It splits this into two. 1, 2, 3. Two ones there, right? -1, -2, -3. This represents integers. Set of whole numbers, 0, 1, 2, and so on, and their negative counterparts. The counterpart of -1, the counterpart of 1 is -1. The counterpart of 2 is -2. The counterpart of 3 is -3, and so on and so forth. Positive and negative integers. Positive integers are numbers greater than 0, and examples include 1, 2, 3, and so on. Negative integers, numbers less than 0. Examples include -1, -2, and -3, and so forth. 0. 0 is an integer that is neither positive nor negative. It serves as the neutral point between positive and negative integers. Number line. A number line is a visual representation of integers where positive integers are placed to the right of 0 and negative integers are placed to the left of 0. Example of a number line is there. All right? Negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. Later, maybe I can produce the visual, the way you draw. But because in mathematics you use squared books, you know that you can fix each number on a certain line and then you create what we call a number line. Excuse me. Opposite integers. Each positive integer has a corresponding negative integer. That is its opposite. For example, the opposite of 3 is negative 3, and the opposite of negative 5 is 5. Opposites are equidistant. They have equal distance from 0 on the number line, but in opposite direction. They are equidistant. They are equal distances from 0. 0 is the neutral point. Comparing integers. Greater than, that sign there means greater than, this one here, this sign, greater than, indicates that one integer is larger than the other. For example, when you write 3 and that sign and then negative 2, you read it as 3 is greater than negative 2. Less than, that sign indicates that one integer is smaller than another. Example, negative 4 is less than 1. Negative 4 is less than 1. On the number line, integers to the right are greater than those to the left. Very important. On the number line, integers to the right are greater than those to the left. Absolute value, which must be known by runners and students. Absolute value, the distance of an integer from 0 on the number line, regardless of the direction, is what we call absolute value. That distance of an integer from 0 on the number line, regardless of the direction. It is always non-negative. So absolute values are always positive. It is denoted by, you put two lines that way, and then you put the number inside those two parallel lines, where A is an integer. Parallel lines inside the A is how you denote it, and A is an integer. For example, the absolute value of positive 3 equals 3, and the absolute value of negative 3 is 3. Basic operations with integers, addition of integers. We will deal with numbers with the same sign. So what you do is you add the absolute values, that is the values without the signs, and keep the common sign. For example, positive 5 plus positive 5, positive 4 plus positive 5 is 9, and negative 3 plus negative 6 is negative 9. And the absolute values, that is 4 and 5, and keep the common sign. The common sign is positive, so you have 9. Negative 3 plus negative 6, and the absolute values which for negative 3 absolute value is 3, and the absolute value for negative 6 is 6. When you add 3 by 6, you get 9, and you keep the common sign, which is negative. The answer becomes negative 9. Different signs. Here you subtract the smaller absolute value from the larger absolute value and take the sign of the number with the larger absolute value. For example, you are adding 7 plus negative 4. All right? You subtract 4 from 7 because 7 has a larger absolute value, you get 3, and then the answer will be given the sign of the larger number, which is positive, and it is therefore the answer of 7 plus negative 4 is 3, positive 3. Negative 8 plus 5, 8 minus 5 is 3, and the larger number is negative, so you have the answer as negative 3. Powerful, guys. Subtraction of integers. Convert the subtraction problem into an addition problem by adding the opposite of the integer being subtracted. For example, 6 minus 4. So you convert the subtraction to addition. So you have 6 plus negative 4. And when you follow the rules, the answer is going to be positive 2. And negative 5 minus negative 3, convert the subtraction problem into addition, which is negative 5 plus 3. And the answer is negative 2. Multiplication of integers. Same sign. Multiply the absolute values. The product is positive. All right? If they have the same sign, that is positive and a positive number, you get a positive product. Negative and a negative number, you get positive product. If they have different signs, you multiply the absolute values, the product is always negative. Negative 7 times 3 is negative 21, and 9 times negative 2 is negative 18. Division of integers. Same sign, divide the absolute value. The quotient is positive. Example, 20 divided by 5 is equal to 4, and negative 18 divided by negative 3 is 6. When they have the same sign, the quotient is positive. Different signs divide the absolute values. The quotient is negative. Example, negative 3 divided by 3 is negative 7. And 9 divided by negative 3 is negative 3. Real life applications of integers. Okay. Temperature. Temperatures can be above or below 0, plus 30 degrees centigrade above 0, and negative 10 degrees centigrade below 0. Banking. Bank balances can be positive or negative overdraft. Example, $200 positive balance and negative $15 overdraft. Elevation. Elevation can be above or below sea level. Example, 100 meters above sea level, positive 100 meters, and 50 meters below sea level, negative 50 meters. Practice problems. Represent the following integers on a number line: negative 4, negative 1, 0, 3, and 5. Number 2, find the sum of negative 7 and 10. Number 3, subtract negative 3 from 8. And number 4, multiply 6 by negative 2. And number 5, divide 15 by negative 3. Summary. Integers include positive numbers, negative numbers, and zero. They can be represented on a number line and have real-life applications. Basic operations are addition, subtraction, multiplication, and division. They follow specific rules depending on the size of the integers involved. These notes provide comprehensive overview of integers, including their definition, representation, and basic operations, along with real-life applications to enhance understanding. Let students add more real-life applications because the ones we have given in the video are not exhaustive. So guys, let's come to that wonderful lesson on integers. We are now okay. Guys, it's an interesting, I've even enjoyed teaching the lesson because I think the details I've given are what is normally required. I've given a very summarized video, okay, or lesson as a teacher. And I've also tried as much as possible to give the most important concepts which should be internalized for you to deal with integers. All right? Remember, integers, if you are weak in integers, then you have no business pursuing a career in mathematics. You have to know those rules. Remember, in the whole mathematics, we have only those four main operations: addition, multiplication, division, okay? Addition, subtraction, multiplication, and division, guys. So, I'm very proud for this video. Please come watch the video from the beginning to the end. Do those exercises I've given there. Discuss with your friend as a student. Come to a consensus and agree that the answers. Look at the reference books and all is going to be well. So guys, that ends my morning session, and we go for lunch so that we next time give you more entertaining, more lovely, more interesting topics in mathematics. Subscribe to this channel. My real name is Mr. Midhamo TK. That's what people knew me, Mr. Midhamo TK. And Mr. Midhamo TK, I told you, has taught for quite some time, especially mathematics. He has evidence of his work in Kenya. He is retired but not tired. So guys, make use of Mr. Midhamo while he is in this world by watching his videos. The YouTube channel is smart_traveler memos, and I promise you, if you watch these videos, you'll be a great mathematician. Bye guys, and see you next time.